Good afternoon, everyone. It's a great pleasure to be here with all of you today. What I would like to talk to you about is that my personal experience at KAIST for the last 4 years. I have been teaching a few different courses, but during this talk, I'm going to go over the one undergrad course, which is electromagnetics. So this is a quick overview. The subtitles are here. I would like to talk to you a little bit about the background of that course. You may know that aspect of the course, but I would like to emphasize that. And then I will do how I motivate the students towards the course in general, and of course, the motivation should be kept all throughout the semester. And then I will mention how I can classify my teaching style, and I will go over one simple maybe case study, and then the final comments and the feedback of the students will be shared at the end. Now, that's an interesting question. If we ask a student with an undergrad degree from an engineering department, saying that, what do you think about the most difficult undergraduate course? Well, you can do that search by yourself as well, just type in that question. And these are the just collected names of the courses. And like Physics 2, Calculus 2, Heat Transfer, Thermodynamics are some of these courses. And most probably electromagnetics is on the list. So, of course, why students find difficult for these courses is that, especially in electromagnetics, we have the physical variables in the form of vector representation, and also we heavily use vector calculus. So we have this bias, maybe prejudice for this course. Even though that's the case, that's, let's say, reputation of the course, over the years, the interest of the student increases starting from fall 2020. So right now, I have around 110 students taken EE 204 course in this semester. All right. Now, the question, even though students find, majority of the students think that this course is difficult, it's my responsibility to grasp their attention and motivation. And what I do is, for example, I have these two examples saying that, assume that we have this, the science and technology that we have today. And if I ask you, can you collect a certain amount of equations that change the world? That's one question. And we all know, maybe you don't know, what's the fundamental forces in nature? So the answer to that question is that among these 17 equations, Maxwell's equations are here, and this is the wave equation in scalar form, but we describe this in its most general form, like in vector form. So this is a quite striking example. The other one is, of course, the fundamental forces, and this electromagnetic force is among them. And by means of this course, you will have a great understanding of these equations and this fundamental force. Of course, there are many other examples I shared just at the beginning of first and second class. For example, saying that if you want to understand how communication is made via wireless communication or fiber optic-based communication, then you should be familiar with this Maxwell's equation. Or if you want to have display applications of light, then you should be aware of the, let's say, wave nature of light and its all properties. So once I explain all these, let's say, great examples, the students show a good interest towards the course, but that's not all. Now, the question, we are familiar with all these types of different teaching styles and strategies, and if I'm asked what is my approach, well, it's kind of maybe conventional or classic one, motivation and objective-centered teaching. So what I mean here is that we have to be tuned at the same resonance. So to be more specific, the main aim is not just like conveying the information and teaching them to learn the new stuff, but it's very important. I have to ignite the desire to learn and explore more. That's important, because I cannot cover everything, and I cannot teach everything maybe in a good level, but if the students can have ignition to desire and to learn more, that's my main aim while I teach. So once we have this same resonance, tuned to the same resonance, then we become a team. Therefore, then I make a role of like coach role versus players roles. So my responsibility is I should show enthusiasm to convey information and to keep them motivated throughout the semester. The player's role, of course, the other side has some responsibility too. They should show high desire to learn, discuss topics, and explore further desire, and desire to explore further. And as I mentioned, the challenging part is to keep the student motivation alive throughout the semester. And again, that's my responsibility. One of the important aspects of my teaching style is that I call this like main dish and different flavors. If I have, let's say, a main dish without any flavor or taste, it may not be a good meal, right? So this is the main dish, maybe the main textbook. All I do is follow the sequence of the topics from that book, but I have additional flavors, collecting the nice examples, nice diagrams, or great explanation of the different topics. As I mentioned, I stick to the sequence of the topics, but I just search different books, different materials, and every semester my lecture notes grows page by page. So I have kind of dynamic lecture notes every semester. So let me show you a case example. Now, this is a very classic example in chapter 5, it's like electrostatic boundary value problems. And we describe this problem, and here we have this second order differential equations, which is just like not appearing correctly here. But now, what I can do is, one approach is, okay, let's solve this boundary value problems and arrive these final equations given here. That's one approach. The other approach is that, okay, this is a maybe tough problem. Let's not bother ourselves, skip the math, and you can study by yourself. Here is the explanation or the final answer. Well, what I do specifically for this example is that let's forget this one. Let's try to guess a solution for this particular problem and find a, let's say, a solution function Vx of y. And then do the math and then make a comparison with this exact solution. And then from the same problem, can we squeeze it down to simple one, like one-dimensional problem, just taking this b to plus infinity, this one to minus infinity, and then approximate this solution as an answer to this simple case? Or can we make a three-dimensional problem and then modify this one? So all these aspects gives a lot of insight for the students just attempting to solve such a problem. But is that all? Well, in my course, that's not all. From this starting point, I ask myself what I can do further is, why don't we cross the border? So this is a problem in like maybe quantum mechanics or solid state physics. Here we have infinite potential barrier and we have a particle electron just sitting here. What are the energy levels and the probability density function of, so this is the, I cross the border and explain this problem a little bit and mention this, let's say, energy levels, discrete energy levels, and the boundary, the potential, the probability of a particles finding in these energy levels. Now, as you see, like from the electrodynamics field, I move to the quantum mechanics domain. Well, I cannot, if I want, I can continue. And then I can mention this similar problem. In this case, students should know that this boundary problems is solved based on Maxwell's wave equation or Helmholtz equation. And then photons are guided just in the middle of this region. Now, we can use our imagination and continue to share further, let's say, aspect of the same problem. The question, if we have a very complex boundary, how can we target that problem? Then the numerical methods are available. And our textbook mentioned only finite difference method, but I mentioned them, method of moments and the finite element method as an additional numerical techniques. Okay, so in summary, by having just this second order differential equation, I myself collected a bunch of, let's say, different equations, and these are just like snapshots of my handwriting notes. In these total maybe 8 equations, I mentioned them in engineering and science. There are plenty of similar equations. For example, this Schrödinger equation is describing this electron's movement, let's say, under different potential energy levels, potential function V. we might have this heat equation or even Navier-Stokes equation. So you see here, I have a very interdisciplinary aspect moving from this electromagnetics domain to lots of different disciplines. And as I mentioned, from example to example, I sometimes mention a problem from signals and systems like image processing, edge detection, machine learning, etc. Therefore, I think it's very important to put an interdisciplinary aspect to our lecture materials. At this point, we all watched this recorded video, and in that video, one of the program that KAIST has is, let's say, this cross program, right? In that program, we have a student, and then the student might have an advisor from different disciplines or different departments. So my lecture notes are quite interdisciplinary. And sometimes I also assign or mention them some research problems and sharing them with some recently published research articles. Therefore, I just remove the boundaries and make it quite interdisciplinary. So due to time limitation, I don't have time maybe to go over all these points, but some more comments. I really think that that's important. I have to be realistic. What I mean here is that we all have a limited time, students have limited time too. Assuming that my students take 5 courses that semester, I can only claim 20% of their time. Well, I can go maybe up to 25 or 30, then it's not fair if I ask maybe 50% of their time. That means there will be less time for other courses for these students. Therefore, we have to be realistic while we are explaining the topics, assigning, let's say, homeworks, etc. We should be predictable, remove uncertainty. What I mean is, based on my experience in the past, like we had exam, and there was a question, and the professor didn't mention at all about that question. Then what's the point if no one knows this aspect of the topic? Therefore, I should emphasize the important parts so that the students should study more to this part. I try to do a friendly environment. I try to generate a friendly environment in my classroom. Engage students in interactive discussion is very important. And I ask awareness, raising questions to grasp the attention all the time. And I don't wait the feedback coming from the students at the end of the semester. I encourage them to provide feedback throughout the semester. And the last 2 comments, if I present my talk like this flow every time, it will be a boring presentation, same as for lecture. So I have to change the flow of the lecture from time to time. I just think about it myself and adapt some solutions. And finally, like when we arrive at chapter 10, the students should have a clear picture of the connection between chapter 1 up to chapter 10. So from time to time, I emphasize the connection between each topics, why we are going to study the new coming topic, and what was the significance of the previous topics. So these are just collection of some feedbacks from the students. For example, let me go over them, some of them all together. It says like I had a very hard time understanding like calculus and physics when I was in freshman year, but from this class I had no issue of understanding concept. So as I mentioned, if a student has a difficulty in physics and calculus, this course could be a nightmare. So I know that, and I do my best to make it clear for students. The lecture was very smooth and interesting. And then it says best lectures and tremendous consideration towards the students. And in this one, I just picked this one because the students like a lot the way that I mentioned this Navier-Stokes equation. And it says the course content is sometimes unpredictable. And I always wait for his lecture and always satisfied from his lecture about fruitful contents. So that's very important. And I'm very glad that I have such a feedback. So like the appreciation of the student is priceless. Now, if I ask if I want to say the final words, we can make a huge impact through a combination of innovative and effective teaching, a great effort and enthusiasm and commitment to our student. With that, I would like to thank you for your kind attention. 감사합니다.